Okay, this video discusses a concept called coterminal angles. So the definition of a coterminal angle is that they are two or more angles that share a terminal point on the unit circle. So for example, the angle 0 radians and 2 pi radians, two different angles, are coterminal because they share the terminal point 1, 0. So what that means again is that the angle 0, which actually 0 as an angle is just a line straight out to the right, and the angle 2 pi, so the angle 2 pi would be this, and then we would go all the way around and we would end in the same location. That's the angle 2 pi. Those are coterminal because they end at the same point on the circle, and that point is 1, 0. Okay. Now, what that means is we can find coterminal angles to any angle on the unit circle. So you should hopefully know that angles don't stop at 360 degrees, right? If you're a fan of the Olympics or X Games or anything like that, you should know that angles larger than 360 degrees exist, right? If we go around 2 full times, that's 720 degrees, right? So the idea is coterminal angles simply just end up in the same location, which means that the cosine and sine of those angles, whatever those two angles would be, if they end in the same location, they're going to have the same cosine and sine values, right? So the cosine of 0 radians is 1, and the sine of 2 pi radians also 1. I'm sorry, the cosine. The cosine of 0, the cosine of 2 pi, both of those are 1. The sine of 0 and the sine of 2 pi, those are both 0, the y-coordinate there. Right? So they're coterminal angles. They're going to give you the same sine and cosine values. So what we're going to do is we are going to give a positive and a negative coterminal angle to each of these angles. And the way we're going to do that, if I want to get a coterminal angle, I simply just have to add a full rotation. If I add a full rotation of the circle, I'm going to end up in the same exact location. So if that's degrees, if I want a coterminal angle to a degree measurement, I add 360 degrees, and that's going to get me to the same location. So a quick example of that would be if I want a coterminal angle to 30 degrees, if I add a full rotation of 360 to that, 390 degrees would also end up in this same location, right? That would be a full rotation plus 30 more degrees. 390 degrees would be the same location as 30, and I got that from adding 360 to 30. A full rotation in terms of radians is 2 pi radians. So what this says is to find an angle that is coterminal to any given angle, simply add or subtract 2 pi. So I'm going to think about every single time that I want to give a positive and negative coterminal angle, I'm going to add and subtract 2 pi to the given angle. So a coterminal angle to pi would be 3 pi, but also negative 1 pi. If I add 2 pi to pi, I get 3 pi. If I subtract 2 pi, I get negative 1 pi. Those are going to both be in the same location as pi. If I add or subtract 2 pi from 2 pi, I'm going to get 4 pi. I'm also going to get 0. That's technically not answering the question. We want a negative coterminal, so I'm going to subtract 2 pi again. Negative 2 pi. Before I move on, anytime that you have a whole number pi, if it is odd, it's going to be in the same location as pi. If it is even, it's going to end up in the same location as 2 pi or 0. Okay, same location there. All right, so I'm going to add and subtract 2 pi to pi over 2. Now, again, what I want to do here, I've got a fraction, right? So I want to think of this as being 2 pi over 1, which means I'm going to be adding and subtracting 4 pi over 2 because I need to make sure that my denominators are the same. So essentially what I'm doing is adding 4 to the numerator and subtracting 4 from the numerator. and I get 5 pi over 2 and negative 3 pi over 2. Those would end up in the same location as pi over 2. 3 pi over 4, if I want to add and subtract 2 pi, that means I want to think about 2 pi as 8 pi over 4. Right? I need a common denominator. So I'm going to add 8 pi over 4. I'm going to subtract 8 pi over 4. And those are both coterminal to 3 pi over 4. 11 pi over 6. If I add and subtract 2 pi from that, I want to think about 2 pi as 12 pi over 6. So if I add that, I'm going to get 23 pi over 6. If I subtract that, I'm going to get negative 1 pi over 6. And then 4 pi over 3, if I add and subtract 2 pi to that, I'm going to think of that as 6 pi over 3, which means we're going to have 10 pi over 3 and negative 2 pi over 3. Okay, so what I'm listing there are coterminal angles to the given angle. For each of the following angles, state the coterminal angle that is represented on the unit circle. So this is a skill that you'll probably use more. You'll start with an angle that is not on the unit circle. 10 pi is not on the unit circle. I want to find the angle that is on the unit circle that is coterminal with 10 pi. So what I want to do, if my number is bigger than 2 pi, I want to subtract 2 pi. Well, that gives me 8 pi. That's still not on the unit circle, so I want to subtract 2 pi again. Well, that gives me 6 pi. Still not on the unit circle, so I subtract 2 pi again. What I'm doing every time I'm subtracting 2 pi is I'm subtracting full rotations, which means I'm going to end up in the same location. 4 pi, still not on there, so I want to subtract 2 pi again, and what I end up with is 2 pi, or 0. That is a unit circle measurement. Okay, so I found that 10 pi is in the same location as 2 pi. Okay, 17 pi over 3, same concept. 17 pi over 3 is bigger than 2 pi, because 17 divided by 3 is bigger than 2. So I want to subtract 2 pi from this. Well, again, remember, if your denominator is 3, you want to think about 2 pi as 6 pi over 3. So if I take 17 minus 6, I get 11 pi over 3. That's still too big, so I want to subtract 2 pi again, or subtract another 6 from the numerator. That's going to give me 5 pi over 3. This is on the unit circle. Okay, so again, 17 pi over 3 is coterminal with 5 pi over 3. They're in the same location. 5 pi over 3. 5 pi over 3 is this angle. Let me erase what I've got drawn on here already. 5 pi over 3 is the angle that starts at 0 and goes to there. 17 pi over 3, because I had to subtract 2 pi twice, 17 pi over 3 actually goes all the way around twice and then to there. So that blue spiral is the angle 17 pi over 3. It's 2 full rotations and then ends up at 5 pi over 3. But the idea is they end at the same location. Right? 17 pi over 3 and 5 pi over 3. Negative 7 pi over 6. Well, this time we're in the negative, so what I want to do here is add 2 pi. So I'm adding, if my denominator is 6, I'm adding 12 pi over 6. That's how I want to think about 2 pi. That's going to end up at 5 pi over 6. And just to show you, I'll use this 17 pi over 3 and 5 pi over 3 idea. Just to show you that these indeed are what we call coterminal. I'm going to make sure I'm in radian mode. I am. If I were to do the cosine of 17 pi over 3, it gives me 1/2, right? And that's something well, let me continue on. We said that was coterminal with 5 pi over 3, right? So that, again, is 1/2. Now that is something you know. If you know the unit circle, you're like, okay, cosine of 5 pi over 3, 5 pi over 3, x coordinate, if I'm doing cosine, that's 1/2. We found that 17 pi over 3 was coterminal with 5 pi over 3, so that where we're going to use this is if I want to know the cosine of 17 pi over 3, I need to figure out that it's coterminal is 5 pi over 3, then I can use the idea that cosine is the x-coordinate there, so I know that because the cosine of 5 pi over 3 is 1/2, the cosine of 17 pi over 3 also has to be 1/2 because 5 pi over 3 and 17 pi over 3 are coterminal. Okay? So that is the idea of coterminal angles. They end up in the same location on the unit circle.